All right, so this is section 13.4, inverses of trigonometric functions. Now, just like you can have, the inverse of multiplication is division, inverse of addition is subtraction, inverse of square rooting is taking the square, inverse of taking an exponent is a logarithm, right? We've learned all about inverses, how to undo certain things. So what undoes the operation of sine? Well, it would be inverse sine, okay? You have evaluated trigonometric functions for a given angle. You can also find the measure of angles given the value of a trigonometric function by using an inverse trig relation. Let me pose this question to you guys. If I had the sine of theta is equal to 0.5. We've been working with statements like this where I say the sine of an angle is 0.5. That's how we introduced right triangle trig, right? I said, what is the sine, cosine, and tangent of this triangle? But I didn't say, okay, what are the angle measurements of that triangle? I could find that, though, using inverse trig. If I said this, the sine of theta is equal to 0.5, I'm saying that some angle theta, I don't know what the degree measure is yet, but some angle theta is equal to 0.5. Now, let me ask you this. What is the sine? Is it x value or y value? Y value. Can we find a location along the unit circle with the y value of 0.5? Look at your unit circle. So what is the angle that has a corresponding sine? What is the angle that has a corresponding sine of 0.5? 30 degrees? Is that true? I guess I should look. I go back here to my unit circle. Let me shrink this down a little bit. I'll need that. So I said, what is the angle with a corresponding sine of 0.5? So where am I finding the y values at 0.5? Okay. I'm finding it here. Anywhere else? Over here as well. So we're actually seeing two locations along the unit circle with that same sine value. So I can say to you definitively that if I've got the statement sine of theta is equal to 0.5, I know that theta either has to be 30 degrees or 150 degrees. Okay, I know it's either 30 degrees or it's 150 degrees. What if I had said to you this? What is the given angle if the cosine value is negative radical 2 over 2? If the cosine value is negative radical 2 over 2, what's the angle measure that has that value? 135. 135, up one. 135. Anywhere else? 225. So I can say if the cosine of theta is equal to negative radical 2 over 2, then you know the degree measure is either equal to 135 degrees or 225 degrees. See, we're actually getting two different options, and we'll see why here in a second. But this is what we're going to be doing today. I'm going to be giving you the pieces of information on the right side, and I'm asking you to find that theta. I'm basically asking you to solve for theta. Well, in any equation, when I ask you to solve for a given variable, and now that's all theta is, right? It's a variable. If I ask you to solve for a given variable, I want to get sine over to the other side. And what operation does that? Well, that would be theta is equal to inverse sine of 0.5. And that's how it would look. That is the inverse trig relation. So if I've got sine theta is equal to some number a, cosine, tangent, whatever, is equal to some number a, to get theta completely alone, to solve for the angle measure, you're going to need to use an inverse trig relation. And that is, you're going to hear me say that statement a lot, where whatever you're doing, if you're doing a word problem, if you're finding pieces along the unit circle, whatever, if I ask you to solve for an angle, you have to use an inverse trig relation. You have to use the inverse sine, cosine, or tangent. The expression sine to the negative 1 power is the inverse sine. Please note that it is not the reciprocal. Inverse sine is not cosecant. Please get that straight in your heads. Inverse sine is not cosecant. Okay, it's not the reciprocal value. It's inverse sine. It's a different operation. A reciprocal value is different. It's it's almost like taking sine theta to the -1 power, right? Not sine -1 of theta, okay? Or of A. All right, again, the inverses of trigonometric functions are not functions themselves. Why are they not functions themselves? Well, because for each input value, I'm getting two possible output values, right? If I think about our good old friend, the mapping diagram, way back at the beginning of the year, and I said, if I give you an input, are you sure, is there only one possible output that I want, that I have, that's available to me? No, there's two possible outputs. Like, for example, think about inverse cosine of 1/2. Inverse cosine of 1/2, there are two locations along the unit circle that have the x value at 1/2. The locations are pi over 3 and 5 pi over 3. Or 60 degrees and, what would that be? 300 degrees, right? 60 degrees and 300 degrees, or 5 pi over 3 and pi over 3. There are two locations. For the one input of 1/2, there are two outputs. That is not a function, right? That is not a function. And actually, I've been mistaken every time I say that there's only two outputs for each input. There's actually an infinite amount of outputs for each input. Why is that the case? Well, because what about, so this is 60 degrees, right? What about 420 degrees? Won't that have the same sines, cosines, and tangents as well? Yes. What would happen if I added another rotation onto that? Would that have the same sines, cosines, and tangents as well? Yes. So it's actually an infinite amount of outputs. Not just two, but an infinite amount of outputs. And couldn't I also do negative rotations as well? So I've got to consider that when I answer these questions. Okay? So let me ask you this. If I have the cosine, inverse cosine of radical 3 over 2, my question is, where on the unit circle do you see that cosine? Look at your unit circle. Where on the unit circle do you see that cosine? Where on the unit circle do you see the x value of radical 3 over 2? 30 degrees? Where else? 330. Now, we need to account, look at the directions. Find all possible values. We need to take into account all rotations. We need to take into account all coterminal angles. And to do that, we almost need to set up like an equation here. So we're going to say plus, now how much is one rotation? 360 degrees, plus 360, and I want to take multiple rotations, right? So plus 360n. I'm going to do that for both the 330 and the 30. Now, can n be any number? Yeah, so what about 0.5? So what about 0.2? I ask again, can n be any number?
No.
What's it got to be? Any whole number? Okay, so what about, there's the word, integer. Because can I go in negative rotations? Yeah, so negative rotations will work. A negative 360 degrees is the same as a positive 360 degrees. So therefore, I have to say where n is a member of the integers, where n element of z. You could write that out in words if you'd like to. Where n is an integer, that would be completely fine. But I like to be fancy. And what if the book had asked me, or what if I had asked you on a quiz or test? State your answer in radians. Let's do that. Because I will ask that from time to time. What is the radian measure of 30 degrees? Pi over, good. And what about in the fourth quadrant? That would be 11 pi over 6. Remember, that's 1/6 less than 2 pi, or 1/6 less than 12 over 6. Now, in terms of a full rotation, what's a full rotation in radians? 2 pi. So we say plus 2 pi n. Where n is an integer. These are just two possible ways to answer my question. If I don't ask you, like, if I don't tell you, like, the directions don't tell you how to answer the question, whether to put it in degrees or radians, you can do whatever you want. So pay attention to the directions. Sometimes it says, state your answer in radians. Sometimes it says, state your answer in degrees. And if it doesn't tell you, you can do whatever you want. Okay, let's take a look at the next one. Now, tangents are a little bit harder to find, right? Because you've got to kind of almost like guess and check at it. But what family always has the tangent of 1?
45.
45 family, right. The 45 family always has the tangent of 1. So I know, now, where is it at? Is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? First and third. First and third. Now, what is the 45 degree in the third quadrant?
135, right?
That's in the second. 225. Why do I know that it's in the first and third? Because this is a positive one, not a negative one. Tangents in the second and fourth quadrant, remember ASTC. If I want positive tangent, I know that it's in the first A, only sine is positive in the second quadrant, T, tangent is positive in the third, and then only cosine is positive in the fourth. So I know that if this is a positive 1 there, because that's a positive 1, I know that it's 45 and 225. And let's add on all rotations. And now let's do radians as well. Why not? Pi over 4. And what's that in the third quadrant? 5 pi over 4, right? Plus 2 pi n, where n has to be an integer. Okay, so we can say that the inverse trig function is not necessarily a function, right? That's why it's been talking about a relation up to this point. The inverse trig relation is not a function. So what if we wanted it to be a function? What if we said, okay, we only want one output for each input? What if we wanted to say, I'm going to restrict sine, cosine, and tangent so that the inverse would be a function? And that's what we're going to look at next. What if we wanted it to be a function? Because more than one value of theta produces the same output per given input, it's necessary to restrict the domain of each trigonometric function in order to define the inverse trig functions. And that's the key word there, function. As soon as I call it the inverse trig function, I'm assuming I'm talking about a restricted domain that only gives me one output for each input. Trigonometric functions with restricted domains are indicated with a capital letter. You haven't even realized it yet, but every single time that I've been writing sine, cosine, or tangent, have I capitalized? No. I've never capitalized sine, cosine, and tangent. Why? Because if you capitalize sine, cosine, or tangent, you're implying that you're restricting the domain. You didn't even know that was the case yet. But if you capitalize sine, cosine, or tangent, capital S sine, capital C cosine, capital T tangent, what you're doing, there's implications to capitalizing that letter. What you're doing is saying, okay, I'm restricting the domain so that when I take the inverse, I'm only possibly going to get one output. Here are the restrictions on the domain, and this goes on to your second page, the top of the second page of the guided notes. Here are the restrictions of the domain for a capital S sine, capital C cosine, and capital T tangent. Now, why am I restricting the domains to those places? Why am I restricting the sine value to only the first and fourth quadrants? Well, if you're looking at your unit circle, where do I have repeating y values? In the first and second, and then in the third and fourth, right? Those are the only places where I'm repeating y values. So if I only want one set of possible y values, I'm going to take the first and fourth quadrants. Now, if I only want the first and fourth quadrants, okay, I've got to say if I'm talking about a closed domain, meaning I'm only going to use one statement to say it, I don't want to say, okay, I only want numbers from 270 to 360 or from 0 to 9. I don't want to do that. I want one chunk to explain where I want my domain to be. Okay? How am I going to do that? I'm going to say from negative 90 degrees to positive 90 degrees. Now you have room over there on the right to write these in, but I'm writing it as degrees now. From negative 90 degrees to positive 90 degrees. So if I say to you, I want capital S sine, and it ends up falling in the fourth quadrant, okay? It ends up falling in the fourth quadrant. You say, well, let me talk about it. Let's say I want inverse sine of this negative 1/2, right? If I say inverse sine, capital S inverse sine of 1/2, of negative 1/2, you know what that's telling me? What location has that? Here. Do I want here? No. For sine, I've restricted my domain to be on the right side. Can I give, is 330 degrees an allowable answer? No, because it doesn't fall within my domain of negative 90 to positive 90. So what's a coterminal angle within that domain of 330 degrees? Negative 30 degrees. Is it negative 30 the same thing as 330? Yeah. Does negative 30 fall within my domain of negative 90 to positive 90? Yes. Okay. So once you use that capital S sign, you restrict the domain. Now, the tricky part is the restrictions on the domain change for each trig ratio. The restriction on cosine, if you look at the values of cosine, where are the values of cosine repeating? Well, look at the x values on the right side of the unit circle. Don't I see some matching x values top to bottom on the right side? Yeah. Don't I see some matching x values on the left side of the unit circle as well? Yeah. So therefore, if I want it to be a function, if I want to restrict it so I only get one output, I'm going to restrict it from 0 to pi, or from 0 to 180 degrees. I know you guys like to think in degrees. So I would write out the degrees as well. The cosine is a little bit better because I don't need to worry about any negative rotation. Because if I just go from 0 to 180, that's going to cover everything. Now, for tangent, the same thing is true about having matching tangent values. But in this case, where is the tangent the same? First and third, and second and fourth. So if I don't want any same tangent values, let's not worry about the second and third quadrants. Let's only worry about first and fourth quadrants. Okay? So therefore, I could do negative pi over 2 to pi over 2. Now, do you notice here that there are no or equal to's there? Why is that the case? If I had done this, what would have happened at negative pi over 2? Or in other words, what would have happened at negative 90? Undefined. This function is undefined at negative 90 and positive 90. So therefore, we do not include the or equal to, right? And again, if you wanted to write that in, negative 90, oops, I put the or equal to, whoops, negative 90 to positive 90. Okay. So the restrictions on, now you got to memorize these, you got to know these. The restrictions on sine are negative 90 to positive 90. The restriction on cosine is 0 to pi. The restriction on tangent is negative 90 to positive 90. Okay. These functions can be used to define the inverse trig functions. For each value of a in the domain of the inverse trig functions, there is only one and only one value of theta. Now that we have restricted these sines, the cosine, the tangent values using those capital letters, I can say that yes, this inverse trig ratio, I can call it now an inverse trig function. Therefore, even though tangent inverse has an infinite amount of values, inverse tangent of 1 has only one value, okay? This is just kind of like summarizing everything for you here. Now, let me ask you this. Looking at your unit circle, what are the only possible range, what's the, how do I put this? What's the range of signs that I could get? Like thinking about it like this way. In terms of the y values, what's the smallest possible y value I can get along the unit circle? What's the smallest possible y value I could get along the unit circle? What's the smallest possible y value that's located on the unit circle? You can go even less than that. I'm not restricting my domain.
Oh, negative.
Negative 1. What's the biggest possible y value I could get? Positive 1. So my range of sign is negative 1 to positive 1. That means my domain of inverse sine is negative 1 to positive 1. Cosine is the same way. Cosine is the same way. Look at the x values. Don't I go from negative 1 to positive 1 with my x values? That means my range of my inverse is going to be negative 1 to positive 1. That means for sine and cosine, I am very limited to what I plug into inverse sine and inverse cosine. Could you actually evaluate inverse sine of 5? No, because it's not within my domain. You're going to get a domain error in your calculator. Could I actually take the inverse cosine of negative 2? No, you're going to get an error in your calculator because that's not within the domain. The domain of inverse sine and inverse cosine are negative 1 to positive 1 because those are the output values for regular sine or cosine. Now for tangent, that goes out the window because I can have a wide variety of outputs. Right? I can have a wide variety of outputs for tangent because if I keep dividing along the unit circle, I'm going to get numbers that either get really big or really small. I'm going to get numbers that are really positively big and really negatively small. Why is that the case? Because as I trace along the unit circle, as the, isn't tangent y divided by x, I can get x values that get really, really, really small. And when I get x values that are really, really small, the bottom of the fraction gets really small, which makes the number big. Okay? So that's what's happening. That's why I see the inverse tangent has a domain from negative infinity to positive infinity. The inverse trig functions are also called the arc sine, arc cosine, arc tangent. I just wanted to show that to you because some books do call inverse trig, inverse sine, inverse cosine, inverse tangent the arc sine, arc cosine, arc tangent. That's more advanced. That's more as you get into calculus or maybe pre-calc. I'm not sure if they ever call that in that there. But as you get into more advanced mathematics, you might see it as the arc sine, the arc cosine, or the arc tangent. If you ever see something like this, sine h or h sine, that is not the same. That's something completely different. That's hyperbolic sine. So that's not the same. That's not arc sine or arc cosine. All right, so evaluate the inverse trig function. Give your answer in both radians and degrees. Now I'm asking you, what is the cosine, inverse cosine of negative radical 3 over 2? How is this different from what we did on the first page? It's capitalized. It's capitalized, and that has a lot of implication, doesn't it? If that's capitalized, capital C cosine, I've restricted the domain. So where do you see the x value of negative radical 3 over 2? Look at your unit circle. Where do you find the x value at negative radical 3 over 2? There's two locations, right? I see 150 and 210. Do I care about 210? No, because cosine capitalized. So I only care about the 150 degrees. There is only one output for this input. What's the radian measure that matches? 5 pi over 6? Yeah. Questions about that? Okay, let's do another one. What's inverse sine of 3 over 2? No, I didn't say radical of 3 over 2. I said, what's inverse sine of 3 over 2? What's the domain of inverse sine? -1 to +1. Would it make sense to plug in something that's bigger than 1? No. So this is undefined. This is like when I said, what's the inverse sine of 5 or something like that. If you do not have a number between -1 and +1, you can't actually calculate the inverse sine. Okay, so what's the inverse sine of negative radical 2 over 2? Let's find negative radical 2 over 2. And am I looking at x value or y value? Y value, because it's sine. And it's capitalized, so that has some implication. So where is the y value, negative radical 2 over 2? Right here, right? Is 315 a valid answer? You may be saying, yeah, it's in the 4th quadrant. That's what I want. That's where I restricted my domain. Well, what is the restriction on the domain? It's -90 to +90. So what do I have to change it into? Instead of 315, I have to call it -45 degrees. That's the coterminal angle that fits within my domain. Remember, the domain is -90 to +90. Yes, I get it. 315 still is in the 4th quadrant, but that's not within my domain. That's not within the restriction. So I can't use 315. I've got to change it into a coterminal angle that fits within -90 to +90. All right, let's do some word problems now. Because now we have inverse trig. Yeah, remember I said this today was going to be a long lesson? We're going to write those up. Because we got to make up for not having notes yesterday. A painter needs to lean a 30-foot ladder against a wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be a quarter of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? See, now what we can do with inverse trig is actually solve for angle measures.
What kind of question?
One that you have to solve.
Thank you.
Okay, so the painter leans a 30-foot ladder against a wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be a quarter of the length of the ladder. So this should be a quarter of the length of the ladder. What is the quarter of the length of the ladder? 30 divided by 4, whatever that is, right? 30 divided by 4, 7.5. I want to find what acute angle should the ladder make with the ground? The ladder and the ground. I want to find my theta. What trig ratio am I going to use to find theta?
Sine.
Sine would be opposite in hypotenuse.
Oh, yeah.
Cosine. Cosine theta is equal to 7.5 over 30. Now, I just capitalized cosine, and I did it for a reason. The reason being, I only wanted one output. Why do I know I only want one output? Because it says, what is the acute angle that matches? So let's find theta. It's inverse cosine, and I should have capitalized that. Inverse cosine of 7.5 over 30. Let's do that. Inverse cosine of 7.5 divided by 30 gets us, that's not right. Why is that not right? Yeah, what is that actually giving me? 1.32, that's 1.32 radians. 1.32 radians. I had to switch it back for calc yesterday because we were looking at radian measure. So if I run that again, 1.32 radians is 75.5 degrees. 75.5 degrees. Oh, to the nearest degree?
What is radians even like that?
76 degrees. Hold on a second. Yeah, that would be 76 degrees. It's just another way to measure angles using the radius of the circle.
But like in real life, does anyone use radians?
Yeah. A
Just
lot.
like in like
Are we not real life?
only talking
Not real life. This is not real life.
But I mean like in the real world.
A lot of engineers use radian measure.
Okay, yeah.
Because
Not real.
Because the numbers are big if you use degrees. But you can always express it as a fraction, as a rational number, if you use radians. A group of hikers wants to walk from a lake to an unusual rock formation. The formation is 1 mile east and 0.75 miles north. Let's draw it out. Okay, so we're at a lake. Here's my lake. It's blue.
Wow.
Yo, it's the weird.
Here's my unusual rock formation.
Like a dog.
It's 1 mile east and 0.75 miles north. And what direction should the hikers head from the lake to reach the rock formation? Trigonometry is used a lot to tell bearings. Like if you're out on the ocean, if you're in the air, if you're in a plane, trigonometry is used all the time to give you direction. Used all the time to give you direction. Because I just created a right triangle to figure out what angle, what bearing I need to go. Like to find my theta here, what trig ratio am I going to use? Opposite over adjacent, which is tangent. And I should capitalize this because I only want one output. Tangent theta is 0.75 over 1, opposite over adjacent. So therefore, inverse tangent of 0.75 over 1 is going to get me the angle measure that I want. Inverse tangent of 0.75 over 1, 30, what's it say, to the nearest degree? Yeah, 37 degrees. So that would be 37 degrees. You know what somebody who does bearings might say? They might say east 37 degrees north. That's how they would call that. That means starting at east, I want to go 37 degrees to the north. That's how they would say that. East 37 degrees north.
GPS says I want to do that.
Yeah. Yeah, like a lot of like ocean, like anything in the ocean and anything in the plane.
Wow.
Oh.
No, I said wow.
Wow. Solve each equation to the nearest tenth using given a restriction. Now, I am changing up my restrictions to kind of play around with it to see if you guys truly understand this stuff. So if I say sine theta is equal to 0.4, now if you see 0.4 on my unit circle? No. So we got to use our calculator. To solve this, I would say theta is equal to inverse sine of 0.4, which is going to give me 23.6 degrees. Right? Does 23.6 degrees, does 23.6 degrees fall within my domain? Yes. Perfect. Awesome. But what if I ask you this?
What?
Is my calculator going to give me a different number?
No.
No. My calculator is going to give me the same 23.6 degrees. However, if you think about sine, I've got 23.6 degrees here. So somewhere out here, right? There's my 23.6 degrees. Where else along the circle has the same y value? Right there. Don't those two places have that same y value of 0.4? So what you have to do, what the calculator is actually doing, is giving you the reference angle. It's giving you the reference angle. And those two angles are congruent to one another. So the only other place that has that same sign value is 180 minus 23.6 degrees. And that you just got to reason through, like finding the reference angle back in section 13 too. So 180 minus 23.6 degrees is going to be 156.4. Does 156.4 degrees fall within my domain? Yes. If it didn't fall within my domain, you would say undefined. Because there are only two locations. Okay, there are only two locations along the unit circle that have that same x or y value. There's only two places that have the sign value of 0.4. It's either 23.6 degrees or 156.4 degrees. Would it have made sense to say this? Sine theta is equal to 0.4 for 270 to 360. Would that have made sense? No. I would say that that's not possible. Because the only places with a positive y value, are there any positive y values down in 270 to 360? No. So you would say that that's a bogus question. So let's take a look at the next one. And notice that C and D are the exact same question, just with different restrictions. So let's find out what my calculator tells me. Inverse tangent of -2 is going to give me -63.4 degrees. Does that fall within my domain? Yes, from -90 to +90, -63.4 does fall within my domain. Let's figure out the only other location with that same value. Now, in terms of my coordinate plane, I've got -63.4 degrees down here. Right, somewhere down there. There's -63.4 degrees. That's the negative rotation. Where's the only other place? What quadrant is the only other place with that same tangent value? The second quadrant. The second quadrant. Because remember, tangent's funky. It's up there with the same reference angle there. Because those are vertical angles, right? I've got two crossing lines. I know vertical angles right here. Those are congruent to one another. So I know that that is the same reference angle. What is my reference angle there? 63.4 degrees. So to find what my true angle is, it's 180 minus 63.4 degrees. 180 minus 63.4 is going to get me 116.6. Does that fall within my domain? Yeah. Sound good. Okay. I'm just going to keep going till the bell rings. Inverse cosine of 0.3 is 72.5 degrees. Obviously, that falls within my domain of my first one. Okay. So 73.5 degrees is up here. The only other place with that same x value, down here. Because those x values are my 0.3. Why am I talking about x values and not y values? Because it's cosine, not sine. So my same 72.5 degrees is my reference angle. So I take 360 and subtract away my 72.5 degrees. Find my true angle out of my reference angle. So 360 minus 72.5 is going to give me my true angle of 287.5. Let me get you the worksheet real quick. Didn't need to remind me. I remember. Yeah, sorry. I knew today was going to be a bell.
Why is that? I'm sick of it. I don't know how
I just like to feel it.
and I don't have to take one.
No, that makes me very uncomfortable. I hate that. Feel that. Like the whole that. No. Yeah. But you like it good.
Oh, I forgot about the. What's going on with the TV?
Line percentage is something.
Oh, I got to stop my video.
of like all the equations.